We have covered the entire foundation, architecture, training, inference, alignment, and limitations. Now we step into where AI stop being just a chatbot and become a system that actually interact with the world. Here is the core problem. LLM are frozen at training time. They don't know today's news, your private document, or stock price. So how do they still give accurate answers? They connect to the external systems. Four technique make this work. We'll cover each one in detail with accurate technical visualization. First one is RAG. That's retrieval augmented generation. Use vector search to find relevant document and inject them as context. Tool calling lets LLM output structured JSON that that an orchestrator could execute against a real API. Agent chain, multiple thought, action, observation loop to accomplish complex task. And then the last one is memory. That is extract key facts from the conversation and persist them for future session. Think of this in this way: a genius with no internet versus a genius with search engines, calculators, and database. Same reasoning ability, vastly different utility. That's why augmentation. That's what augmentation provides. RAG is the most important modern technique for reducing hallucination. Let me show you exactly how it works. The process has three stages: embed the query to a vector, search for similar document, chunks, similar document chunks using cosine similarity, and then inject the top results as context before generating. Watch this animation because it's sort of showing the actual technical process. On the left, you see the user query. What is the refund policy for software license? That query gets converted into a 768 dimensional vector by an embedding model. You can see the actual numbers there, right? Like 0.24 minus 0.8891, etc. Now look at the central panel. That's the vector database. Each document chunk has already been embedded during indexing. The system computes cosine similarity between the query and vector, query vector and every chunk. You can see the scores, right? The refund policy document score is around 0.92. The license transfer document scores around 0.84, while pricing and support documents score much lower, right? 0.41 and 0.38. The system ranks by similarity and select the chunk above a certain threshold. Let's suppose in this case, the top two documents with scores above 0.7, right? We select them. Now watch the right panel. The retrieved document chunks get injected into a prompt as a context. The system prompt says answer using only the provided context. Then the actual context appear followed by the user query. The LLM generates based on this augmented prompt, producing a grounded answer that directly references the retrieved document. This is why RAG reduces hallucination. The LLM never memorized your company policy. It reads retrieved document at the generation time, like a open book exam. Answers are grounded in actual source text, not training memory. Okay, the next one is tool calling. RAG handles strict documents, right? But what about calculations, live data, or actions? That's where tool callings, comes in. The key insight is that LLM output structured JSON specifying a function name and arguments. That's the key insight, right? That LLM output a JSON format which has function name and an argument which that function needs. An orchestrator layer parse this JSON, execute the actual function, and inject the result back for the LLM to synthesize. Okay, look at this animation. User asks what's 847 times 293 and the weather in Tokyo. The LLM's internal reasoning identifies it needs two tools, calculator for maths and weather API for Tokyo. Now watch the LLM output. It generates a structured JSON object, right? You can see here. It it generates like a function name which has calculator and arguments containing the expressions 847 and times 293. This isn't a natural language, it's precise schema that the orchestrator can parse. The orchestrator receives this JSON, routes to the calculator function, execute it and return the result. That is if you calculate, it will come out to be 248171. The result get injected back into the conversation. Then LLM generate another tool call for the weather API with city Tokyo as the argument. The orchestrator calls the weather service, get back the temperature 22 and the condition that is partly cloudy, right? Finally, the LLM synthesizes both results into a natural language response, which comes out to be, I was reading it as 847 times 293 equals 248,171, and Tokyo is 22 degrees Celsius and partly cloudy. The key insight is that the LLM doesn't compute anything. It generates structured requests, external systems execute, the LLM synthesize results into a natural language and use it. It's an orchestrator, but not a calculator. Okay, the next one is agent. Tool calling handles single function call. But what about complex task that requires multiple steps where each steps depend on the result of the previous step? Agent reasons interactively using something called as a react pattern, right? That is thought, action, and observation. Repeating until the goal is achieved. You repeat thought, action, observation, these three steps until the goal is achieved. Look at this animation. This is an actual sort of scratch pad that an agent maintain. Watch how reasoning is unfolding. The goal is to research Tesla stock and explain today's movement. First thought is that I need current price first and then news to explain the movement. So the first action comes after that. That is web search for Tesla's stock price for today. Notice how the action is specific function call here with parameters. Then we get the first observation. The search return that Tesla is trading at maybe 248.50, right? Up to 2.3% for today. Now watch iteration 2. The agent thought analyzes, okay, got price data, stock is up 2.3%. Now I need news to explain why, right? Then comes the second action, that is web search for Tesla's news today, right? That is Tesla news today catalyst. Second observation comes after that action. Headline about so maybe India factory announcement and Q3 deliveries beating the estimates, etc., etc. Then comes the third iteration. The agent thought concludes, found the catalyst, I have enough info to answer. And finally, the answer synthesize everything. Tesla is at 248.50, up 2.3% today. The rise appears driven by the India factory announcement and Q3 deliveries beating the estimate by 4%. Okay, now look at the state panel on the right here. You see the goal, right? Iteration, counter incrementing as well, right there, and status changing from reasoning to complete once you have completed the reasoning. Each thought decides the next action. Each action calls a tool. Each observation informs the next thought. The loop continues until the goal is achieved or maximum iteration has reached. This enables complex multi-step tasks that would be impossible with a single tool call. Okay, the last one is the memory. That is the final technique. How do you maintain context across separate conversations? Memory system extract key facts from conversations, store them persistently, and retrieve relevant memories in future sessions. Watch the phase process here. On the left, session 1 conversation is happening where user says, I'm building a Flask web app for my startup. Assistant respond, and then user adds routes also. I prefer concise code example, right? Now watch the extraction step. The system identifies key fact. Tech stack is Flask and Python. Project is a startup web app, and preference is concise example. The arrow that you see here, activate as these facts flow to the long-term storage. That is on the right side. On the right, you see how facts are stored. Structured data with the user ID, technology stack, and project status and preference. This persists across session. Now in session 2, when the user asks about the Flask, the retrieval arrow gets activated, right? And the system search stored memories, find relevant context and inject it into the new conversation. The LLM knows this user prefers concise answer without being told again. This enables personalization, continuity across sessions, and efficiency. No repeated context explanations, right? But it raises the important considerations. What's stored, what can access it, who can access it, how long it's kept, and whether the user control their own data. Even with all these techniques, fundamental challenge remain. Retrieval error happens. Wrong document get matched. Relevant chunks are missed. Embedding don't capture semantic nuances. Tool failure also occurs, right? APIs sometimes timeout. LLM generates malformed JSON or calls the wrong functions entirely. Agents loop can get stuck in some infinite cycle. Maybe hallucinate impossible plans or take unsafe actions. And context limit means you can't fit all the retrieved document. You must rank and truncate potential missing information. Potentially you can miss the information because you are ranking and truncating it. Production system needs guardrails to prevent harmful actions, validation to check outputs, fallback to handle failures gracefully, human oversight for critical decision. Augmentation helps dramatically but doesn't eliminate the need for careful system design. This is how AI powers a real product today, okay, in production. Enterprise Copilot, right, combines the RAG over internal documents with tool calls to company APIs. Support bots uses knowledge base retrieval plus ticketing system integration. Research agents perform um, multi-step search and synthesis with citations. Code Assistant combines Codebase RAG with actual code execution and test running. The production stack is always the same pattern: LLM for language understanding, RAG for knowledge grounding, tools for real time data, memory for context persistence, and guardrails for safety. That's the complete architecture. Okay, let's verify that everything is connected. You can read the statement here, right? And let's walk through it and try to sort of unwrap it. LLM becomes reliable through RAG, that is vector search plus context injection. Through tool calling, that JSON function protocol with the external execution. Through agents, that is thought action observation loops for multi-step reasoning. And through memory, fact extraction plus persistent storage. Together, these ground patterns prediction in real information, right? So, the patterns get grounded and you get much reliable information. If that makes sense to you now, you understand modern AI deployment. Now you have covered everything from architecture through production deployment. Okay, so what comes next? In the future video, we'll look at some advances, right? Multimodal models, handling text, images, audio, and video together, chain of thoughts and tree of thoughts reasoning, AI autonomy, and future architecture that might extend or replace transformer. That's frontier territory. Okay, see you in the next one.